Hello there, it's motor test of the week. This week going to be testing this it's another GoolRC motor. Really like these ones. I bought mine a while ago, but for some reason now the sellers on eBay aren't shipping to the UK. Really annoying. As you can see here, it now says do not ship to the UK, which is annoying. I'm glad I got at least one of these a while ago. But anyway, yeah, it's a GoolRC 2968 3400 kV 4-pole in-runner motor. They're meant for boats, but you know me, I like planes. So yeah, going to give this one a run. This one I'm putting in a ducted fan, but it's a bit of a hybrid fan unit. But let's have a look at the motor. Let's have a look at the specs. Yeah, it's quite a nice. They're quite nice, these motors. They look pretty good. Yeah, nice big holes at the front for cooling. They're built pretty sturdy. Yeah, nice motors. Comes with the connectors. Yeah, as you can see, nice big holes on these ones. There's copies of these and they don't have the holes, so these ones probably stay a bit cooler. Let's go down, have a look at the specs. Here we go. Right. Yes, it's 2968. It's 3400 kV. It says it's capable of 60,000 RPM, which is crazy. And it's 1800 watts. At 17 volts, which is yeah, that's a bit mental. Let's have a quick look at what that is. So what we got, 1800 divided by 17. That technically means it can take a total of 105 amps of current draw. 105 amps, pretty crazy. Yeah, 1800 watts. Seems quite a lot really for a 29mm in runner. What's the weight? The weight is 188.6 grams in weight. So it's, yeah, not too bad. It's quite heavy, but yeah, it's not bad for that. But yeah, being a 29mm in runner, so you may have trouble getting it in a 28mm housing for a ducted fan, like I did. I'll get onto that a little bit later. But yeah, let's have a look at what I bought. Basically, I bought a couple of these. I bought one, and I did a sort of a motor conversion to be able to run a bigger motor in this, because I think, like I said in that video, it's quite stupid being a high powered fan, as in it takes a lot of power to run it. The hole diameter for the motor is only 20mm, so it's kind of a bit stupid really, because you can't run these at sort of power they're designed for. And I also I don't like the adapters that come with them. They're just don't know, they don't grip very well, and I'll get onto that in a moment. But basically I wanted to try and do a really high powered setup, and I couldn't find any motors that would work with this ducted fan, because it's just, I don't know, it just draws so much power, and even the motor that I fitted it in the other one was struggling to run it, even being a low kV motor, and it was running on 6S. But I wanted to, it worked out quite well because it was reasonable thrust for a low current draw. I think it was only about 36 amps it was drawing, but thought I wanted to do a bit more powerful setup. See what I could run, because this see, I've seen these on other sites, and the specs it gives here are a bit different. This is max power of 1300 watts. I've seen another site where it said maximum of 1400 watts, and it says 38,000 RPM, which is why I set up for the other one. Was what I thought was bang on, because it was running at about 37,500 RPM, something like that. So it was about what I thought it could take. But I've seen another site where it had the same sort of fan, and it said max of 50,000 RPM. So, you know, you don't know. Maybe they didn't think they could take it or not, I don't know. So basically what I've done is, to be able to run this rotor, 12 bladed rotor, with a 29mm inrunner, is I also bought a couple of these, although I got mine a while ago from a different site, and the ones I bought, the place where I bought them, it lists it as a 65mm fan. This is listed as a 66mm fan. So don't know what's going on there, but I found these to be pretty decent fans. These are an old design. I've seen these. These have been knocking around since early 2000s. But actually, I think even from the 90s. These have been knocking around from the 90s. And this is basically a new design, well, a copy of those old designs. But I found them to be pretty good. I've run one of these up with a decent motor, and I've had 1300 grams of thrust out of it, so they're pretty decent. It does say this EDF motor will take a maximum diameter of 29mm, but that's not quite the case. It didn't quite fit the motor, so I did have to Dremel out a little bit, only a little bit, out of the inside of where the motor goes, and yeah, it fitted in there nicely. So what I've done is used this housing to house the motor, but fitted the fan blade from this fan in this housing. So it worked out pretty good. I mean, it says it's 66mm, but to be honest, the fan blades fit in there fine. There isn't too much of a gap around the side. It fits in quite nicely. I think it's a bit of an exaggeration of 66mm. So, because yeah, not quite. Let's see if the conversion there is quite right. So it says 2.56 inches. So what's that? That's 2.56 divided by 25.4. No, that's wrong. What am I doing? That's wrong. 2.56 times 25.4. See, yeah. So their conversion's wrong there. It says it's 66mm, but 2.56 inches is only a fraction over 65mm. So Hobby King's conversion there is a bit wrong. Yeah, it is a 65mm fan. So Hobby King, you should correct that. It's not 66mm, it's 65. But I did find that the fan blades in this housing, they're very close to the outside of this. So to be honest, they're slightly oversized for that housing, but they fit fine in this housing. Yeah, and this one comes with a nice big duct lip, so that's pretty damn good. Right, so I'll just finish up here and I shall show you the modifications I've had to make and go through a bit more on the trouble I've had with this motor. Right, let me set up on the bench. Right, here we are. This is the original housing. It's the Chainsun one, even though they're not listed as Chainsun on Hobby King site. And like I said, I don't like this because it's only got 20mm hole for where the motor goes. And I mean, you saw my other video, I did make a standoff mount and got a motor in there, 28mm motor. But it's, you know, I had to run 6S to get any sort of decent power out of it. But it's pretty good, nice low current draw. But yeah, this one is kind of don't like it. The other thing is, I mean, because it says it's rated up to 1300 watts, but how many 28mm outrunners with a standoff mount do you know that would go down to a 20mm hole? How many of those do you know that puts out 1300 watts? I can't find any. I'm telling you, if I can't find them, I doubt anyone else can. So I don't like this. So that's why I changed the housing. The other thing is, even if you did run 1300 watts and put out a decent amount of thrust, these units, they've only got a tiny little single tab, mounting tabs with one hole. I don't know about you, I would not trust that tiny little tab with one screw in it to hold that into the plane or on the test bench, whatever. I don't know, I would not trust that. You can get these Chainsun fans now, and I think another one which is pretty much the same copy. Oops. You can get these now that do fit up to a 30mm or 29mm motor. The hole there is a lot bigger, like I was saying they should do, and lo and behold, they have them now. You can get them with a much bigger mounting thing, but like I said, they've still only got a single mounting tab on either side, and I would not trust that. I don't know, I just don't know if I would trust it. I mean, I could cut that off and make your own bracket, but screw it in, but that means having screws through the side. Don't know, but yeah, anyway. But the other thing I don't like is the adapter that come with them. The one I'm using is a 4mm, this is the 3.175mm one. But for some reason they come loose. I don't know what it is, they come loose, and even though you've got it done up as tight as you can, which is annoying with the 12 blade rotor, because you can't get your fingers in. I've got short stubby fingers, me, and I can't get it in. I can't grip the fan rotor to be able to do it up enough with a spanner or whatever to be able to get it to grip really well. The only way I was able to do it with my other fan, I mean, that had an outrunner that I'd made fit with a standoff, is I had to put the motor in a vise and then hold the fan blades and then do it up, and I was able to get it up just enough with that, because that one kept undoing as well. So yeah, basically these come undone, which is really annoying, and I was suffering with that quite a bit with this fan. It would start running up and then it would come loose and it would start vibrating, and also I couldn't run it with the original nose cone, because it would vibrate like mad with that on it as well. I couldn't get it to run with that either. It was just terrible. So the inside of the housing is scuffed like mad, where it kept suddenly going off. It's balanced, but it would just suddenly go mad and just hit the sides, even though there's a reasonable amount of room. So basically what I had to do was got one of these. This is off a 6mm prop adapter, and luckily they do fit the thread, and it's a reasonable fit to the inner hub of the fan blades. So that's what I've had to do. And also, even then, I had it running pretty good, and I was going to do the test, and then it come loose again. You could see it had shifted on the shaft, even though once you've taken it off and you've taken the fan blade off, you can't pull it off the shaft. It's locked solid. You have to hold the end and then tap it with a hammer. Well, keep tapping it with a hammer until it sort of shakes loose. Once you've held the bit, the little hub bit there, you hold the hub bit and you keep tapping it with a hammer until it pops off. But which I find really funny, because you can't pull it off. You can't pull it away from the shaft by hand. You're putting all the force in the world in it, and it won't come off. But if you run it up, it starts to sort of come off the shaft like that. It's ridiculous. So it really annoys me. There's something about the way these are machined inside. I think they just don't grip the way they do. So what I had to do was use a bit of thread lock. I had this high strength thread lock. I got this from Hobby King, and I've used basically I have used this a couple of times on stuff which I did want to try and do, and I could not get it undone. It's basically, I've tried it on prop adapters, used it on prop adapters to do it up, and then I needed to change the blade, change the propeller blade. I couldn't get it off, and I've ended up snapping the prop adapter, because the lock on this is so strong. So, but I know it's a high strength one, but basically, if you're going to use this, don't put it on anything that you might want to get undone in the future. It sets like mad. So I've had to I just put a couple of drops inside the hole of the adapter, and basically put that on the shaft, because I read that some people, that's what they do. So I'm hoping that has cured it. I'm hoping that has stuck on, because I put it on there last night, and I've left it overnight to dry, because I was trying to sort it out last night, and it just kept coming loose. So I put a couple of drops in the hole, refitted everything, done it all up, made sure the fan blade was balanced properly, and done it all up and left it overnight. So hopefully when I do the test in a moment, it's cured the problem. So that is the finished result. Let me just move that out of the way. As you can see here, I was a bit worried about the housing because it had a little bit of flex in it. So what I've done is I've got this stuff here, which is real carbon fibre. It's only a small sheet, as you can see here. It's not that big. I did have a load of this because I was at a model show, and a guy had loads of offcuts or something, and so these were, I don't know, these were only about, I don't know, a foot square bits or something. They were offcuts. He had a load of them, so I bought a few of them, but I wish I'd bought the whole bucket load that he had. I should have taken more money with me, really. But what I do is just pull one of the strips off, pull the weave strips off, and then with 30-minute epoxy, I've just wrapped it round the housing like that, some longer bits, and just glued it on with 30-minute epoxy. So I've put a load of those round there. It's a bit messy on that side. That's where the glue started to go off, and I was trying to get it all stuck on, but this side's a bit neater. So I've got loads of strands around there, and that really stiffened up the housing because I was a bit worried about what was going to happen with this. But yeah, so that's the result. That's how I've got it all done. And it looks alright. There's a little bit of a step there. Yeah, there's a little bit of step, but it's as good as I can do, really. And I hope this is going to work a bit better. I've given it a little bit of a run up, and it seems to run a bit smoother. I need to put it on the test rig with the fully charged batteries and give it a run. So yeah, hopefully this will put out a reasonable amount of thrust. This housing though, I still may use it because I have the fan rotor that came with this housing, so I still have this one. Comes with I think it's a 3.175 shaft adapter, and it's a nice grub screw one. And these fan blades are pretty decent. It's 6 blade, sort of the old style rotor blades though. They don't look like these anymore. You know, thin at the hub and thick at the end, but they put out a reasonable amount of thrust. Like I said, I've run one of these up to pretty good power, and they sound quite good in the air as well. Sound pretty good. So all I'd have to do really is just cut a tiny bit off the blades, probably about 1.5 mil or something. I think 1.5 mil, and I can use that fan blade in that housing. I just have to get I can just get a simple motor that will have the 20 mil reduction adapter and run that. It won't be super powerful, but you know, it's another ducted fan, isn't it? And it makes use of the housing rather than paying for just the blades. So at least I can make myself another ducted fan out of that. Alright, so basically let's get this on the thrust stand and give this a whirl, see what sort of thrust this is going to put out. You can see all the scuffing where the blades have hit the sides. You can see this motor is pretty powerful by the way that sort of shift turns like that. Pretty decent motor, or pretty powerful motor. Yeah, you can see there isn't that much of a gap there, so it does fit it reasonably well. So yeah, let's get this on the thrust stand, see what sort of power it puts out. Okay, here we are, all set up. Let's give you a quick rundown on the setup. I've just got a simple red brick ESC. I just used this because it had the right size connectors on, and it's already all set up and programmed, so I didn't have to do anything with it. We'll use a smaller ESC on this if I stick this in a plane. I'm just going to be running it on 3-cell. Have a zippy 2200 milliamp 40 amp C3 cell. So that's what the 3-cell test is going to be like. So let's see what power it runs and then move on to the 4-cell. Alright, let's hope the modifications I've done all work. That seems to run a lot better. Only 58 amps, only 650 watts. That's not bad. Don't sound quite whiny. Let's have another go. That's good power on 3 cell. A good amount of thrust. Check the old temperatures. 33.6 degrees. Yeah, 33.6. Right, so let's chuck on the 4 cell. Okay, got the 4 cell plugged in using a 2700 milliamp 60C Zippy Compact 4S 4 cell. This could be a bit crazy, but let's see how this goes. Blimey. Cool. 1200 watts. 87 amps. Blimey. Hmm. Hmm. 36. Oh, can focus. 36 degrees there. Yeah, 36 degrees. Let's give that another run. Cool, 90 amps. Blimey. Hmm. 40 degrees on the nose there. Right. Well, it seems to be staying together at the moment. Let's give it another run. Oh, it does feel warm. .48 degrees. Not overly bad, really. Yeah, 48. Blimey, that's stepped up the power on the 12 blade rotor. Seems to be able to take it. Definitely don't think I'll be attempting to run that on 5 cell. That would be a bit stupid. Yeah, these motors are supposed to take 1800 watts, but that might be on it says it's rated to 17 volts, so that's not really a 5 cell, and it's not really a 6 cell. Sorry, not really a 4 cell, I meant. But the voltage drop could go down to about 17 volts on 5 cells, but Yeah, I want to get one of these again and try it with a propeller, because I think one of these with a prop on in a pilot racer would be crazy. But yeah, that's 90 amps, 1308 watts. It's yeah, it's quite a lot of current draw really. But it's certainly stepped up the power. I think that would sound mental in the air. That would sound crazy. But yeah, that's seems to be staying together. So I think that's a good job there. I would like to take that motor out and stick a prop on it, but now I've got it all set up, I don't want to take it apart. Apart from the fact that I've Loctited in the shaft. But anyway, that was this motor test of the week on the GoolRC, was it 2970 3400 kV. Yeah, that's pretty damn good, that. Quite a high current draw, but loads of power. Right, anyway, if you like this video, click like and subscribe. Doing motor tests every week, trying to do some crazy ones like this. And then yeah, I'll just be doing some basic ones as well. But anyway, thanks for watching. Bye bye.